This is your first video for Combinatorics. We are using the Grimaldi text, Discrete and Combinatorial Mathematics. We're covering Chapter 1, Fundamental Principles of Counting, and this lesson is over 1.1, the Rules of Sum and Product. The first thing I would like you to understand about this course is that it's much more complicated than it might seem just learning rules and formulas. So, for instance, in this one lesson, I'm going to show you 3 different methods using the rule of sum, using the rule of product, and using the opposite problem. And while each of those in their own right are very straightforward, when we're actually asked to apply those to questions, it will be much more difficult. So what I would stress to you is learn all of the strategies that I'm going to teach you, but always think outside of the box as well. So there are many ways, many correct ways to solve each problem. So just make sure that you know the method that you're using well enough that you know it leads to the correct solution. So instead of just providing you with the rule of sum, let's talk about how we might arrive there. I have 2 dice, one green, one purple. How many ways are there to get a sum of 7 or 11? So typically what students do starting out is say, I could get a 7 with 1, 6, 2, 5, or 3, 4, and I could get an 11 with 5, 6. And so they'd say there are 4 ways. But as we can see, it's not quite as simple as that, because 1, 6 and 6, 1, even though they're kind of the same, I'm rolling 1, 1 and 1, 6, and I've color-coded them so you can see which die was which color. 1, 6 and 6, 1 should both be options for us. 2, 5 and 5, 2 should both be options for us. 3, 4 and 4, 3 should both be options for us. And then 5, 6 and 6, 5 should both be options for us. So how many ways are there to get a sum of 7 or 11? Well, there are 6 ways and 2 ways, so there are a total of 8 ways. So this brings us to the rule of sum. The rule of sum states that if I have 2 tasks, one which can be performed in m ways and one in n ways, and the 2 tasks cannot be performed simultaneously, which means they are disjoint, which is essentially saying when I roll, I can't get both a sum of 7 and 11 at the same time. I could get a sum of 7 or I could get a sum of 11. Then tests A or B can be performed in m plus n ways. So what I want you to start to associate is when you see something that's or, you should be thinking plus. So if I'm saying A or B, I'm going to be adding those possibilities together. Here's an example. This is from your textbook, page 11, number 1. During a local campaign, 8 Republican, 5 Democratic candidates are nominated for president of the school board. If the president is to be one of these candidates, how many possibilities are there for an eventual winner? Well, again, this is very straightforward. There's 8 Republicans, there's 5 Democrats. One of them is going to end up being president of the school board. So let's just add those together to get our 13 possibilities. So quite often what I will do is provide some practice questions which go above and beyond the examples that we go through together. So whenever you see one of these, PR1, PR2, etc., those are practice that if we were sitting in a classroom together, I would ask you to turn to your partner and work together to solve these 2 or possibly solve them on your own. Since you're watching this video instead of being in a classroom with me, what I'd like you to do every time you see one of these is to press pause, take your time as you would in a classroom to read each question, to try each question, and then when you are ready, I would like you to press play to see how you did. So hopefully you did actually press pause and try these questions and you're not just waiting for me to go over them. Question 1, we're looking at a woman who's deciding to go shopping, and she's either going to go north or south. And if she goes north, she's going to visit a mall, a furniture store, or a jewelry store. So going north provides us with 3 options. If she goes south, she's going to shop at a clothing store or a shoe store. So going south provides us 2 options. This is a very straight up rule of sum question, All I have to do is add the two together. 3 plus 2 equals 5 possible shops that she could go to. And again, that's answering the question that was asked. Question 2, not quite as straightforward. This one says a computer science instructor has 2 colleagues. One has 3 textbooks on the analysis of algorithms. Great reading, I'm sure. And the other has 5 textbooks. If N denotes the maximum number of different books on the topic that the instructor can borrow, give the possible values for N. So key word here that I want to point out is that we're talking about different books. So a lot of people would just say, well, if one has 3 and one has 5, that means there's 8. And you're partially correct. There are 8 possible textbooks that I can borrow from my colleagues. However, because I'm looking specifically for different books, and it doesn't specify if the first colleague and the second colleague have different textbooks, it could be that all 3 of my first colleague's textbooks are also in my second colleague's textbook library. So what I'm going to do instead is say that there are up to 8. 3 plus 5 does equal 8, just as we said before, but it's possible that there's an overlap of 1, 2, or 3 of those textbooks. So it's possible that only the 5 that I get from my second colleague will have 5 different textbooks. So anywhere from 5 to 8 inclusive. So previously we looked at example 1A, which was in your textbook on page 11. Now I want to look at part B of that same question because I want to talk about the rule of product. So during a local campaign, 8 Republicans and 5 Democrat candidates are nominated for president of the school board. This question is different. How many possibilities exist for a pair of candidates, one from each party, to oppose each other for the eventual election? Now, obviously, there's a very simple way to do this using the rule of product. If we didn't have the rule of product, you might have to make a tree diagram. So a tree diagram, in case you don't know, is something where I would put my 8 candidates that are Republican. 1, 2, 3, 4, 5, 6, 7, 8. And off of each of those 8, I would pair them with each of the 5 Democratic candidates. So each of these would have 5 branches, and I'm not going to draw those branches. And that would be the 1, 2, 3, 4, 5 candidates for Democrats. So if I needed to know all of the different possible combinations, I would have to make a tree diagram. But what I'm looking for are just how many options are there. So if I don't care about what the actual combinations are and just need to know the number, I'm going to use the rule of product, which looks similar to what we said before for rule of sum. If one is m ways, one is n ways, notice if it's A and B, then I'm going to multiply. So again, you should start to associate and with multiplication. So going back to our question, there are 8 possibilities from the Republican Party and 5 from the Democratic Party. The number of possibilities is found by taking 8 times 5, because I'm using 1 Republican and 1 Democrat. So I get 40 total possibilities. So here's another practice for you, and again, some of these will be very straightforward and some not so much. So what I want you to do is press pause, try all 3 questions, then press play to see how you did. So I'm starting by looking at a student ID made up of 3 letters followed by 2 digits, and it says how many possible IDs exist. So starting to look at this, I would say there's 3 letters and 2 digits. So letter, 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 digit, digit. Well, how many letters are there? There's 26. And there's no restriction right now. It doesn't say I can't repeat letters, so there's 26 3 times and 2 digits. Digits are the numbers 0 through 9, which means that there are 10 digits. So that's going to be my first solution. 26 to the 3rd times 10 squared and multiply it out. Now in terms of answer format, if you're able to show me both how you set it up and the solution, that's great. Sometimes, especially later on in the course, we're going to have numbers that are so large that this will be your final solution and you won't have to multiply it out. But for now, please show me both. For B, it says how many IDs are possible if duplicate letters or numbers aren't allowed. So let's take a look at how my little display at the top might change. If I have 26 letters for my first option, then my second option is now 25 letters because I can't use whatever letter I used here. And then my third letter, I only have 24 options because I can't use whatever letter was second or first. For my digits, I've got one digit that can be anything that I want it to be, 10, but my next digit has to be anything except for what I chose here. So that's going to be my new solution, 26 times 25 times 24 times 10 times 9. And again, I found that as a raw score as well. Last one, this one's a little bit tougher. How many student IDs are possible with an even number of A's? So first we need to think about the fact that we have 3 letters. So it's possible to have 0 A's, and it's possible to have 2 A's. But just like we talked about before, where 1-6 and 6-1 should both be options, I have different possibilities for where those A's will go. So let's take a look at how I broke this down. And quite often you'll see your work like this. Here are my 3 different ways that I could have 2 A's. So I could have AA and then some other letter, A, some other letter A, or some other letter than AA. So those are all the different ways that those could happen. And then whatever number I have here and here. So what do those look like? Those are all one option for the A's and 25 options, which is every letter except for A, for the other space. So if you'll notice, the 3 of these are exactly the same. I put the 25 in the different place to signify where the blank was, but really this is just 3 of the exact same thing. For the last one, for 0 A's, I know that there are 25 options, which means not anything but an A, anything but an A, anything but an A, and then of course 10 squared. And all I did, add all of those up to get my final solution. Let's take a look at our last concept for section 1.1, which is the opposite problem, also known as the complement. Now, you should be familiar with the word complement. Previously, when we learned about probabilities, we would say the probability of not A would be 1 minus the probability of A, or vice versa. That's what the complement is all about. Now, when we did this with probabilities, we used 1 because 1 was all of the probabilities put together, because we know that a full sample space needs to be 1. So let's take that same concept and apply it, instead of probabilities, let's apply it now to the number of options that can occur. The part D of the same question that we were just working on with student IDs says how many student IDs have some repetition, which means if I were going to do this without the complement that we haven't learned yet, I would have to find what happens if I had 2 A's here and then some other number and 2 B's and some other number and 2 C's and some other number, and then I would have to put the A's here and here, and then I would have to put the A's here and here, and then I would have to put the A's all over, and then B, 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 and C, 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 and I haven't even looked at the numbers yet. So you can see that if I was trying to do this using the rule of sum, there would be just so many options that I would have to find, and it's very possible that I would screw up and forget one. So instead of doing that, because that would be ridiculous, let's take a look at the complement. The complement of having some repetition would be no repetition. So if I can find how many where there are no repeats, no repetition, and subtract it from the total, like I did up here, but the total won't be 1, it will be the total number of options, then I'm in business. That's how we use the complement. So let's take a look at how I might do that. If I were looking for the total sample space, well, we already kind of figured that out. We said that there were 26 to the third times 10 squared, because there were 3 letters and 2 digits. So that's what I have here. That is IDs total sample space. The no repeats is obviously a little bit harder, so I'm going to say there are 26 options for my first letter. I can't repeat, so that's 25. I can't repeat either of those, so that's 24. And then again, we have 10 for the first digit, but I can't repeat that digit, so there's 9. So again, this was an answer to a previous problem that we did, as was this. And notice now I'm just subtracting the 2 to find my total answer of 353,600. So let's take a look at this last question. And some of these are pretty straightforward and some not so much. So what I would encourage you to do is to take your time on this. So it's very tempting to just not press pause and not try these questions on your own first. And I would discourage you from doing that, because as I go through them, you're going to say, oh yeah, that's sure, that makes perfect sense. But when you're actually trying these on your own, before you know the answer, you're going to have that moment of struggle where you're thinking, I don't know how to do that. And that's a very important moment, because that's when you are learning how we can apply what we know. So press pause, try all 6 questions. When you're ready, press play to see how you did. So before I started this question, I just started by looking at this without even looking at A, B, C, D, or F. I said, I've got 6 numbers. And I didn't look at any of the restrictions except for it says no leading zeros. So I know that the digits include the numbers 0 through 9. So the first digit can be not 0 through 9 because it can't be a leading 0. So my first digit could be 1 through 9. But any of the rest of my digits can be 0 through 9. So how many options is that? Well, I know 0 through 9 is 10 options. And obviously 1 through 9 is 9 options. So that's a really good starting point. I have an idea of what the question is all about before I actually am trying to answer anything. So now let's try to answer the first question. It says no digit may be repeated. Alright, so let's use kind of what I came up with at the beginning and change it a little bit. My first digit, still 9 options, because I can use any digit that I want except for 0. 1 through 9. This guy can be any digit except for whatever I put here. So there are still 9 options because I can use 0 now, but I can't use whatever the first digit is. For my next option, I can use anything except for what either of these two are, which means now I only have 8 digits left because I've used 2. And then I have 7 digits left, and 6 digits left, and 5 digits left. So that's what I'm looking at for A. No digit may be repeated. 9 times 9 times 8 times 7 times 6 times 5. For B, digits may be repeated. Well, good news. I already determined that one right up here. If I can repeat digits, that's what I came up with at the beginning for the total sample space, is 9 times 10 to the 5th. So now that we've done the easier ones, let's take a look at the ones that may hurt your brain a little bit. This one says no digit may be repeated and it's an even number. So we're kind of looking at this one, but we're saying this guy has to be even. So you might be thinking, well, that works because there's 5 even numbers, so let's just go with it. Okay, that's not going to work. Here's why. I have this restriction right here that says this guy can't be 0, which means when I have an even number, which is a number that would end in 0 or 2 or 4 or 6 or 8, making it even, this guy is going to come into play because the first one can't be a 0, and that's going to change some of my possibilities. So what I have to do is actually think of 2 cases. So let's look at these 2 cases. If it ends in a 0, then I've got my 9 options at the beginning, which is anything except for 0. Then anything except for 0 and whatever is here, and then anything except for 0 and whatever is here, and same pattern. And then this guy, there's only one option because that is a 0. So that's my first possibility. My second possibility is that it doesn't end in a 0 and ends in one of my other even numbers. So that's 4 options. So this guy can be anything except for 0 and except for whatever this is. So I kind of started at the end. This guy can be anything except for whatever this is and whatever this is. So there's 8 options. This guy can be anything except for those we've already assigned. Same here, same here. Of course, it's decreasing by 1 because each time we assign one more. So then I show that work and show that then I'm finding the sum of those two possibilities. So whenever I break them into cases, that's a rule of sum. But then, of course, I was using rule of product to find the probabilities of each case. So if at this point you'd like to press pause again and try D, E, and F again, if you didn't get them the first time, that would maybe be a good idea. Otherwise, we're going to forge ahead. Here we have digits may be repeated, and it's an even number. So this one's much more straightforward because I've got 5 different options here for ending in an even number, 0, 2, 4, 6, or 8. And it's okay if we repeat things. The only restriction, of course, is that 9 at the beginning because I can't use a 0. So D is pretty straightforward. For E, no digit may be repeated, divisible by 5. So if it's divisible by 5, what is my number going to end in? It's going to end in a 0 or a 5. Well, as you can see, that's going to bring me back to a question like this where I'm going to have cases because I've got that restriction with 0. So really, I'm going to have the case where it ends in a 0 and the case where it ends in a 5. And here's what that looks like. If it ends in a 0, I have one option for the end. I have 9 options here, everything except 0, then 8, 7, 6, 5. So basically the same pattern we used before. If it ends in a 5, again, one option here. Here I have 8 options. Why? Because it can't be 5 and it also can't be 0. So that's why there's only 8 instead of 9 options. And then 8 here because it can't be a 5 and it can't be whatever I used here. And then it continues to decrease from there. So that total sum, 28,560. And last one, this one's a real bear, so if you got this one, congratulations. This one says, no digit may be repeated and divisible by 4. The difficult thing here is that if it's divisible by 4, I can't just say that it ends in 2, 4, 6, 8, or 0, because that just makes it even. And of course, there are even numbers like 2 and 6 and 10 that are not divisible by 4. So I have to take this guy to the next level. I have to think about numbers that are divisible by 4, which are 2 digits. So I would start thinking about 0, 4, 0, 8, 1, 2 being the last 2 numbers, 1, 6 being the last 2 numbers, etc., etc., etc. Why would I do that? Because I need to know what all of the options are, and then I have to go back to what I learned here and here about my zeros. So let's take a look. We looked at 2 digits being divisible by 4, and notice what I've done is I've broken them into a group that includes a 0 and a group that does not include a 0, because again, I'm looking at my 2 different cases. So my first case includes a 0, and that means there are the 6 options. And remember, that's the last 2 digits, so I'm only going to be multiplying 5 items instead of 6. Then this guy starts with 8 options. Only 8 because I already have the 0 here and then whatever number other than that I used. So there's 8 left, and then it decreases from there. For ends does not end in a 0, there's all of these guys. There are 7 options here because it can't be a 0 and it can't be either of the numbers used here. but then 7 for the next option because it can't be this guy or these guys, but it can be 0, and then it decreases from there, and then 16 for the last two. Adding those together, I get my final solution of 33,600. Good work.